but she wanted a project that would allow her to get some experience with electronics, with mechanical engineering, as well as software. She ended up choosing the omnidirectional robot, which is a great combination to get experience with general engineering, and she's clearly learned a lot from building this project.
Hi, I'm Holly. I'm a rising senior at the Urban School, and my starter project was a voice changer, and my main project is an omnidirectional robot. So like Liam was saying, I didn't have any experience and making robotics and engineering, and so I thought that this would be a good beginner project because a lot of previous Blue Stamp students have done this project, so I knew I would have their pages for reference. So how it works is it moves forwards, backwards, right and left, and then diagonally, and then it also spins. And so how it works is I have this PS2 controller, and I can control the robot with these analog sticks. And then I have a PS2 controller receiver and an Arduino board, which is a microcontroller, so it's basically the brain of my robot. And so the receiver can pick up signals from my controller and basically tell the Arduino that, like, say I move the analog stick up, and then I've coded my Arduino to understand that when it gets a signal like analog stick has been moved up to that I want the motors to move the robot forward. The other key components are the motors, and I guess it was kind of a difficult thing that was the motors can only move laterally, so to make up for longitudinal direction, I had to code the motors to work together to, like I said, make up for longitudinal direction. So to move, say, like diagonally, these two front motors will work together to move longitudinally, and then the back motor will move laterally to, move left and right. And so my biggest challenge was my robot, like one day I turned it on and it just started like moving on its own and spazzing out. So I had to figure out what was wrong with it, and because there's nothing that will like tell you what's wrong with your robot, you have to basically just do like trial and error. So I had to rewire everything and try a new receiver, try a new remote, and then finally I figured out it was the Arduino. So yeah, I just switched it out, and then for my modifications, I wanted to add sound reactive LEDs, which currently aren't working because when I combined my omnidirectional code with my LEDs, the motor started to spaz out again. So I'm planning on working on fixing those in these next 2 days, and by like rewriting my LED code. But the way it's supposed to work is there's a mic that picks up amplitudes, which is like the volume of music, and so it takes amplitudes and gives the volume a numerical value. So say like you're like listening to music and it's at an amplitude of 10, the microphone will read that, and then I hooked it up to my Arduino, and I code my Arduino to know that like when there's an amplitude of 10, I want the LEDs to flash blue. So like looking back at this experience, I like came in knowing I wanted to do robotics, like in the future probably, but after doing this project, I realized that what interested me the most was the modifications, and so I realized now that in the future I want to continue robotics, but I want to make robots like with a purpose, so like possibly like medical technology or something.
From the audience, have any questions?
So you've already shared what the most difficult part of your project was, but what was the most fun part of your project?
even though they don't work, definitely the LEDs, was like super interesting for me, because I forgot to touch on this, but I do sound engineering at my high school, and this was just a really cool way to like expand my knowledge of sound, and like it was cool to combine like robots with sound.
So if you had to start over again, hypothetically, what would you do differently? How would you rebuild it to be even more robust?
I'd definitely be a lot neater with my wires, and I don't know. I'm pretty happy with how it turned out. Actually, one thing that I did was I used to have like a triangle shape, and that was just like too small. Like the surface area was too small. So starting with a hexagon from the beginning and like saving those 2 days I spent making the triangle would have been helpful.
The hexagon's like pretty perfect looking. How'd you make it?
I actually used a CNC mill, and it's basically like it's like a saw, and you connect your computer to the saw, and you can send an image, and the saw just like it does it. It's a robot that cuts out the shape for you.
Holly, do you mind holding, tilting it up, possibly? How many drivetrains are there? 3 or 4?
Sorry.
How many wheels?
No, 3.
3.
Good.